Today we're going to be looking at section 2.3, getting information from the graph of a function. So sometimes the graph is going to be important for us to be able to read and get specific information from, and that's what we'll be focusing on today. This is a very important concept as you move into calculus for those of you that will be going into calculus. Okay, a couple things to keep in mind. The height of the graph is always the value of the function. So sometimes in a problem it'll say like give the function value. If you see the word value, then that's going to be asking for the y coordinate and not the x coordinate. So just keep that in mind. Okay, on this example here, we have a function t that's graphed. It gives the temperature between noon and 6 p.m. on at a certain weather station. So we're asked to find a couple different values. So before we would have an equation for t, but now we have a graph to get our information from. So t of 1 just means that this is the x or my input, and I've got to get the output or the dependent value out from that. So if I put 1 in, I'm going to go up and I'm going to read off my graph, and so that looks like it's going to be 25. T of 3, I'm going to go over, and that's going to be 30. And T of 5, if I go up and over, looks like it's going to be 20. So the question is, which is larger, T of 2 or T of 4? So T of 2 looks like it's going to be about 34. T of 4 is definitely lower, and that's going to be 25. So the larger one there would be T of 2. Okay, in part C, find the values of x for which T of x equals 25. So here it's giving me the y value or my dependent value. So I'm going to go to where y is 25, and I'm going to trace this back over. So I want to find the x's where that happens. Okay, so it's 25 here and it's 25 here. So the x for this 25 is 1, and the x for this other 25 is 4. Okay, so those will be the two values of x for which T of x equals 25. So T of 1 is 25 and T of 4 is 25. Find the values of x for which T of x is greater than or equal to 25. Well, we already located where it was equal to 25, so we have to kind of look and see where is it greater than that. So I'm going to draw this straight line across here, at least as straight as I can draw it. So this particular graph is above 25 for this interval here. Okay, so I want to give the x's where that happens. So the x's where it happens is everywhere between 1 and 4. So for this interval in this part, this is where this is above 25. So my interval for this would be from 1 to 4. And because it's equal at those endpoints, we're going to put brackets on that. Okay, and finally find the net change in temperature from 1 p.m. to 3 p.m. So at 1 p.m. we already said it was 25 degrees. So that's going to give us the ordered pair 125. And at 3 p.m. we've said that that is 30 degrees. So if you remember, net change is f of b minus f of a. So that's going to be f of b, so f of 3. Sorry, this is not writing good. So that would be f of 3 minus f of 1. So f of 3 is 30. F of 1 is 25, and that's going to be 5. So if we look over here at the interval from 1 to 3, okay, so here is the value at 1, here's the value at 3. If I look at this, I have a net change of 5 units. It goes up 5 units from here at 1 to over here at 3. So our net change here is the 5. Okay, here's one that I would like for you to practice on yourself, and then I will show you what the answer should be for this one. Okay, check your answers here. On the first one, h of negative 2 should be 1, h of 0 is negative 1, h of 2 is 3, and h of 3 is 4. I'm going to come back to the domain and range in just a minute. Find the values of x for which h of x is 3. So if we go in and I look at this horizontal line here at 3, the places it's touching is here, here, and here. So that would be negative 3, 2, and 4. The values of x for which h of x is less than or equal to 3, that's going to be this whole part here where it's less than or equal to 3 because 3 is across here. So this is the part of the graph where it's less than that. So from negative 3 to 2. But I'm also going to have to pick up this point here because this point actually equals 3. And since this said less than or equal to 3, I do need to pick that point up as well. If it just said less than 3, then I would have had parentheses here, and I would not have had to include this part. Okay, for the net change between negative 3 and 3, net change is f of b minus f of a. So we were looking at the interval from negative 3 to 3. So this would be my a and my b. So f of 3 is 4. If I go up here, it's 4. F of negative 3 is 3. So my net change is 1. And I can actually see that if I'm looking over here, the difference between this point and this point, and I apologize, this pen does not let me draw good straight lines. But you can see that if I look at this, I'm going up 1 unit over that interval from negative 3 to positive 3. And that's where this 1 unit of net change comes from. Okay, for the domain and the range, I'm going to take some of this off here. Okay, so for the domain and the range, the domain is basically the x's and the range is the y's. So I want you to think about if I was going to draw a rectangle that is going to encompass this graph, but it's not going to be any bigger than it has to be to get all of the graph included, then that's going to represent basically my domain and my range. So the domain on this, if I wanted to look at drawing this box, my domain is going to go from negative 3 over here to positive 4. So from negative 3 to positive 4. I always read from left to right for domain. And then for the range, I'm going to read from top to bottom. So from bottom to top. So I'm going to look here at the bottom being here and the top being up here. Okay, so my range is going to be from negative 1 to 4. Again, going from bottom to top. And so this is kind of just showing you what I was talking about. For the domain, you're always going to go from left to right. And for the range, you're always going to go from bottom to top. Okay, so I've got a couple of graphs that I want us to go through and find the domain and the range on. These like this that you see on WebAssign, unless it has a point, then we're going to assume that they're going on forever. Personally, I've always seen these with arrows drawn in, but they're kind of indicating that, that it should be there. So if I'm looking at a graph that looks like this, and I want to determine my domain, because these arrows are continuing to go both down and out, then what I have for my domain is negative infinity to positive infinity. So over here is negative infinity, over here is positive infinity. So it's going from negative infinity to positive infinity. Or another way to think of that is all real numbers. On the range part, the range we said goes from bottom to top. So there is no bottom to it because these arrows indicate it just keeps going forever in the negative direction. So they're actually down here at negative infinity. But there is a top to it. So the highest it ever gets is here at 1. So my range is going to be 1. Okay, here's another one. The domain on this one, again, assume this has arrows on it. So the domain is going up and out. So it's coming from negative infinity, and it's also going up and out in the positive direction. So the domain would be negative infinity to positive infinity. The range on this one, go from bottom to top. So there is a bottom on this one. The bottom's down here at, it looks like 1, 2, 3, 4, 5. So it looks like it goes down as low as -5 and goes up to infinity. Okay, here's one. Again, assume these are going in each direction. So the domain on this one, it's going down and out. So it's going from negative infinity. Here it's going up and out. So it's going to positive infinity. So negative infinity to positive infinity. The range, same thing, is starting down here at negative infinity and going all the way to positive infinity. So this one's going to be all real numbers for both the domain and the range. Okay, this is another one that the domain is going to be all real numbers, and the range is also going to be all real numbers because, again, consider these have the arrows on them, so they're going up and out and down and out, so it's going to cover all of the values here. Okay, this one, if I look at the domain again is going to be from negative infinity to positive infinity because it's going down and also out at the same time. It's just slightly going out, but it is going out. And then the range, it's starting down here at negative infinity, but it does actually have a top to it. So if we look at this, the highest value that it ever gets to is here at 4. So 4 is going to be my range, the top of my range. Okay. You can do these by being given a function and putting it in your calculator. So if you put this in your calculator, then sometimes you have to get the calculator to tell you what the maximum or minimum is in order to identify the range. So just as a reminder, we did this a couple classes ago, but you'll go to second trace and use either number 3 or number 4 to find your minimums or maximums if you need to do that. So here I have the graph shown of this square root of 4 minus x squared. So when I look at this, the domain is going to be everything from -2 to 2. The range is going, remember with the range, you go from the bottom to the top. So my range is going to start at 0 and it's going to go to 2. So domain, you give x coordinates. Range, you give y coordinates. All right, we can also look at solving some of these graphically, some of the inequalities graphically. And we did this again in the section where we talked a lot about calculators. So I'm not going to spend a lot of time on this. Here we've got 2 equations. You would put this in for y1 and y2. We're looking to see where they intersect. So you can do, just as a reminder, you can go to second trace on your calculator and choose number 5, and it'll allow you to find these points of intersection. On this one, if we're looking for where they equal each other, then you're just going to give the answers here of -0.5 and then also over here at 3. If you're looking for where this is the parabola or the U shape here, where the parabola is less than or equal to the line, that's going to be this part here where that's happening. So that's going to be everything from 1 to 3. So it's going to be the interval from 1 to 3. And then if I'm looking for where the parabola is greater than the line, that's going to be these parts out here because it's above the line here and it's above the line here. So my solution for part C is going to be from negative infinity to -0.5 and then from 3 to infinity. And I would use parentheses because there's no equals part underneath that. Okay. All right, increasing and decreasing functions. This is a big concept in calculus, knowing where functions are increasing and decreasing. And obviously they go in more depth than what we're talking about here. But basically, always think about going from left to right. So an increasing function, if read it like you read a book. So if you're reading from left to right, if I'm moving across this graph from left to right, then this part is rising. So if it's rising from left to right, it's increasing. And if it's falling from left to right, it's going to be decreasing. So it's rising, falling, rising. So this is going to be increasing, decreasing, increasing. And when you're asked to give the interval that it increases or decreases on, always use parentheses. You're not even going to have to worry about brackets or parentheses. Just always use parentheses. And the other thing is you want to make sure that you're given x coordinates for these intervals. So here, like I wouldn't give any y's, I would only give it in relation to these intervals here. So like the rising interval or the increasing interval would be from A to B. And then again over here, C to D. And the decreasing interval would be B to C. All right, so the formal definition, f is increasing on an interval I if f of x sub 1 is less than f of x sub 2, whenever x sub 1 is less than x sub 2 in the interval. So basically, if x sub 1 is to the left of x sub 2, and the function value at x sub 1 is less than the function value at x sub 2, then we have to have an increasing situation. Here, if x sub 1 is less than x sub 2, and f of x sub 1 is greater than f of x sub 2, then you're going to end up with a decreasing situation. Okay, here's one for you to practice finding the domain, the range, your intervals where it's increasing and decreasing. So try this one, and then we'll take a look at your answers. Okay, for the domain on this one, it looks like with our domain, this is going to be -1, -2, 3, 4, and 5. So we're going to start over here at -5, and we're going to go over all the way to +5. Because if I drew these vertical lines here, then one at -5 and one at +5 is going to capture this entire graph from left to right. Moving from top to bottom, or from bottom to top, our bottom value here is -1, 2, 3, 4, 5. So the smallest value here is -5. It goes up as high as 0 because I would have this horizontal line drawn across here at 0. So keep in mind these have to be x values and these have to be y values from left to right. So this is decreasing. Okay, so we've got decreasing, increasing, decreasing, increasing, and decreasing. So if I'm going to write my increasing intervals, remember I always write these in terms of the x's. So this x here is -5. This one is -3, -2, -1. This one is 2, and this one's 5. Okay, so here from -5 to 3 is where it's decreasing. So I'm going to list that for my decreasing interval from -5 to 3. And then here from -3 to -2 is where it's increasing. And then from -2 to -1, this is the part where it decreases again. Then it's going to increase from -1 to 2, so from here to here. And then it's going to decrease again from 2 to 5. Okay, and so we want to union all of these together, and that'll give us our answer for this. Notice it didn't really matter what the y's were on any of these. It was only the x's that we were using to give our increasing and decreasing intervals. Okay, here's one for you to practice on, and then you can check your work. Okay, these are the answers that you should have gotten here. F of 2 is 3 because we're going to go by the closed circle, not the open circle. The domain, when we look at it from left to right, starts at -4 and ends at 4, and every value is covered in between. So if this happened to have been an open circle, then I would have had to have excluded 2 as part of the domain. But even since it's included here, even though it's not here, then every value between -4 and +4 is included in the graph. The range will look from bottom to top. So it starts here at 0. Remember, we give the y's for our range and ends up here at 5. So between 0 and 5. The interval where it's increasing here. So that's going to be from 0, and this should be 0 to 2. Okay, so 0 to 2, it's increasing. As far as interval where it's decreasing over here from -4 over to 0, and then again from 2 to 4. So this is another decreasing section of the graph. Is it a function? It is a function because it passes the vertical line test. Here, if we're looking, we have a solid dot here, but an open dot here. So it would pass. Like the only place it looks like might be suspicious as far as failing would be here, but since this is an open circle, then it does still pass. Now, if this were closed in, it would fail the vertical line test. The net change from -4 to 0 is going to be here at -4, the value is 5, and at 0, the value is 0. So 5 minus 0 gives us a net change of 5. Okay, here's one I want us to identify the intervals where it's increasing and decreasing and give your answers in interval notation. So we're going to kind of break this up. Okay, you can see that if I look down here, this is a minimum, and it's also the place where we change from decreasing to increasing. This is another place that we change. Here's a place that we change. Here's a place that we change. So this part we're going decreasing, increasing, decreasing, increasing, decreasing. So my increasing intervals looks like I'm going to go from -3 to 0 for this part. So -3 to 0. And then I'm going to be increasing again over here from 2 to 5. So that's going to be another increasing interval. For the decreasing part, it's decreasing here. And again, interpret this as an arrow on these. So it's going to be from -infinity to -3. Because at -3 is where it changes from being decreasing to increasing. It's going to decrease again over here between 0 and 2. And then it's going to decrease again after 5. So it's going to be from 5 to infinity. All right, here's one that you're asked to find increasing and decreasing intervals, but you're just given the equation. So what I would say do is put that in your calculator for y1, and we're going to find the domain and range and also the intervals where it's increasing and decreasing. So you're graphing your calculator. Once you maybe adjust your window a little bit, your window doesn't have to be exactly this, but it will be helpful if it's something close to this. Again, interpret this as having arrows here. So our domain is going to be from -infinity to +infinity. Our range is going to start at -infinity because the bottom part is starting at -infinity. And then it's going to go all the way up to this value here. And we're really not sure what the scale is here. So what you're going to have to do is you're going to have to actually use your calculator and find the maximum, find the coordinates of this maximum. And whatever the y coordinate is going to be what we identify for the top part of the range. So if you use that feature on your calculator, what you're going to find is that this point here is the point 232. It looks a little different than that because our scale on the x-axis is showing 0.5s. So this would be 0.5, 1, 1.5, and 2. So if you were to go through and calculate the maximum, you would see that the maximum is at the point 232. So when you go across here, that tells me that it goes up as high as 32. So my domain then is going to be up to 32 and ending there. So this will be 32. So sometimes you have to do a little investigative work on the calculator to determine how high or low it actually goes. I wanted to mention local maximums and minimums. We've talked a little bit about this earlier. On a graph like this, where you've got these arrows that are going in each direction, we're not going to be able to find an absolute maximum or absolute minimum because they go on forever in each direction. So what we'll find are what's called local maximums, and that just means in a given region, that's kind of the largest value there. So this one would have 2 local maximums and 2 local minimums on that graph. Okay, so this one at the local maximum and minimum, all the local maximum and minimum values of the function and the value of x at which each occurs is what we're looking for here. So here we have a local minimum, and that coordinate looks like it's going to be at -3 and -6. So this would be -3, -6. This is at the point 0, 0. This one would be 2, -4. And this one is going to be 5, 2. So if we want to find the local maximums, my local maximums are occurring at x equals 0 and at x equals 5. And the maximum value at x equals 0 is 0. And at x equals 5 is 2. Okay, so the maximum value here at 0 is 0. The maximum value at 5 is 2, because you remember on the very first slide we said that the value is the y part of that. So if we look at our minimums, we have minimums that occur at x equals -3, and that minimum value is -6. And we have another one that occurs at x equals 2, and its minimum value is -4. Okay, we want to look at the intervals on which the function is increasing and decreasing. So we've got for our increasing part, we're increasing on this interval here. So we would be from -3 to 0. Again, only look at these x's when we go across here. And it's also increasing on this part of the graph here. So that's going to be 2 to 5. It's going to be decreasing from -infinity to -3, which is this part of the graph. It's going to decrease here from 0 to 2. And then it's going to also decrease over here from 5 to infinity. Again, these should only be x coordinates because each of these maximums are kind of dividing our graph into sections here. So within each of those sections, then it's going to be always decreasing or always increasing. So on this one, we're asked to find our local maximums and minimums given the equation. So you would put that in your calculator and do your second trace, which brings up your calculate menu, and find the maximums and minimums. That way, it's not sufficient to just trace using the trace key on the calculator. So once you go through that process, and we've talked about that in the previous lecture. Okay, so we see that we have a maximum value of 9.709. And that occurs at when x is -1.633. And then when you locate the minimum, we're going to see that we have a minimum value of -7.709, and it occurs when x is 1.633. And again, we've done that on some other videos. That's section 1.11. So if you need reference for that material, go back to the very end of the video for section 1.11. Thank you and have a good day.